Alright guys, so this is going to be our last section, and we're going to use proportional relationships in order to basically do measurements. So the first definition we're going to get down is an indirect measurement, and we're basically going to be using the fact that we have similar figures, and because of that we can set up a proportion to measure an object. So basically it's called indirect because you're using similar figures and a proportion as opposed to just putting a ruler down and measuring a distance or measuring an object. So the first thing we're going to do is we're going to use an indirect measurement in order to find the height of this pineapple. Okay, so we'll call this x. Now, I want you to go ahead and get this down. This is going to come into play for some of your homework for this example and for some problems that you might see on your assessment. So whenever dimensions are given in both feet and inches, meaning this example right here, this dimension is given in feet and inches, you need to go ahead and convert it to either feet or inches. You guys will see me convert it down to inches. I think it's a little bit easier than building it up to feet. But if you have a different way of doing it, then that's perfectly fine as long as it's accurate. Okay? So a student wanted to find the height of a statue. The sun is shining down and creating a shadow. Okay? So this is going to be the shadow created, and this is going to be the shadow created. Now that's important because the rays are coming at the same angle, making these parallel lines. Because they're parallel lines, you can assume that angle 1 is congruent to angle 2 by your corresponding angles, and we also know that these are right angles. So that we can assume that these triangles are congruent by your angle-angle similarity. That's a little FYI. Now we can get down to business. So what we're going to do, guys, is step 1, I'm going to go ahead and convert these to inches. All right, so this is going to be 24 inches here. I'll use that symbol for inches. This is going to be 105 inches. And it tells me here that her height is 5 feet 4 inches. So this is going to be 64 inches. That's really the only detail that you have to be careful with. Shadow to shadow equals height to height, so we can set up our proportion. Shadow to shadow is going to be similar to our height, and again I'm in inches, and you end up getting x equals 280 inches, and if you get a problem like this, I want you to take it back to your feet, okay? So divide out your 12, and you end up getting 23 feet 4 inches, just to take it to that extra step and have that extra detail. So now, this is going to be a little bit of a counterexample. A proportion can compare measurements that have different units. You guys will see this here. We have a scale, so that means that 1.5 centimeters on my map equals 300 meters in real life. Because of the fact that I'm not combining meters and centimeters in one measurement, and it's apples to oranges and apples to oranges, that's going to be perfectly fine. Okay, so that's a detail to keep in mind when you guys are doing your homework. And to notice. If your answers are off, that might be one of the problems. You will see this again. So let's get this definition down. A scale drawing is basically going to be an object that's smaller or larger than its actual size. All right, so this is going to be your scale drawing. It's usually going to be smaller, guys. This is going to give you your scale right here. Okay, I'm not going to, in your book, it's going to have you do a few different measurements and use a ruler. I'm not going to have you do that. I'll give you guys what the measurements are when you guys are working in class tomorrow. So you don't have to worry about getting out a ruler and messing with that, so it's a little more consistent between our answers, okay? Your scale is going to be your ratio of any length in the drawing to what you see in the real world, okay? So again, it says use a ruler to measure the distance. The distance is going to be 6 centimeters from, let's see, Union Station to the Dallas Public Library. So this is going to be 6 centimeters that we're going to use. So 1.5 centimeters on our scale equals 300 meters in real life. Well, that means that 6 centimeters on our scale is going to equal how many meters in real life? And that's our question mark. So really similar, you guys would have seen these kind of proportions, this kind of problem in Algebra 1. Do your cross multiplying, and you end up getting your x is going to be 1,200 meters. And again, because it's a clean conversion, apples to oranges, you don't have to worry about doing any kind of converting from one unit to the other, as you did in the previous. Okay, so here's another example. We're going to go through one more example where you can see how the scale is going to matter, and then we'll change gears for one last concept. So our Lincoln Memorial in DC is approximately 57 meters long, and it's going to be 36 meters wide. So units aren't going to matter in this case. Okay, now our scale, basically you guys, you know your scale is going to be your similarity ratio. Our scale is 1 centimeters to 15 meters. Again, we're not having to worry about any kind of conversion because it's a clean break, okay? So I want to find the length and the width. So I'm going to set up a proportion for this, for my length, and I'm also going to set up a proportion for my width. All right, so I know that 1 centimeters for my scale equals 15 meters in real life. All right, I want to figure out, if I was going to make a scale drawing, how many centimeters would 57 meters coincide with? Do your cross multiplying, and your length is going to be 3.8 centimeters. All right, so this distance right here is going to coincide with my 3.8 centimeters. We're going to do the same proportion for our width. All right, so I know that 1 centimeter in real life is going to be, or 1 centimeter on my scale is going to be 15 meters in real life, which means how many centimeters in my scale is this 36 meters in real life going to represent? Cross multiplying and you get x equals 2.4 centimeters. Okay, make sure you guys are putting your period at the end of the sentence. I'm going to be looking for that. Y'all did a great job on that in your quiz. Keep doing it. So these are the different scale examples that you guys will see. Okay, this one is one to kind of just look back on just to make sure you're feeling good with it, because again, you have to set up 2 proportions, so it's just a little bit different. All right, the last thing we'll go over, guys, is our relationship between our perimeter and our area ratios. This looks a lot more complicated than it is, okay? So just to talk you through it really quickly, and then we'll kind of get to the meat and potatoes of it. If you guys want to just follow along, if I'm going from triangle ABC to triangle DEF, my similarity ratio is 1 to 2, which you guys will see here, okay? Now, if I go through and find my perimeter, you'll also notice what? The similarity ratio for the perimeters is 1 to 2. Notice I'm going in the same direction. That's going to be important. Y'all did a great job with that. Keep doing it. Now, if you guys notice the areas, 1/2 base times height over 1/2 base times height, what do you notice? It's not a direct relationship being it's the same thing, but there is a relationship there. It's actually going to be your similarity ratio squared, okay? So let's write that up. I don't really care necessarily that you guys know what this is called, all right? I want you to know what it means. So if the similarity ratio of 2 similar figures is A to B, okay, so your similarity ratio is A to B, that means the ratio of the perimeters is going to be A to B, and that means the ratio of the areas is going to be A squared to B squared, okay? Or if you want to think about it like A over B squared. All right, so similarity ratio is the same for perimeters, it's squared for area. So let's go through our last problem here and see how this is going to apply. All right, so it tells me they're similar. That's important, so I can use my relationship. I want to find the perimeter and area. So this has a couple levels to this problem right here, guys. Okay, first of all, step 1, let's find our similarity ratio. And I'm going to go from the order it gives me, RST to UVW. Okay, so 16 over 20 is going to simplify to 4 over 5, so my similarity ratio is 4 over 5. All right, now it wants me to find the perimeter. It gives me the perimeter of this guy. So that means that the perimeter of 36 over x, I want to find the perimeter and area of this guy, okay? That means that 36 over this has to equal what? 4 over 5. It has to equal that similarity ratio. So that's your key step right there. Cross multiply, simplify, and you get x equals 45, okay? So that means that, just to make sure we're crystal clear, the perimeter of this triangle here is going to be 45 feet. This is your final answer right here, guys, okay? Because again, the fact that 36 over 45 simplifies to 4 over 5, which is our similarity ratio and the ratio of perimeters. So for our third one, we want to find the area, okay? Well, I know that the area relationship, the similarity ratio is 4 over 5. That means the ratio of the area is going to be 4 over 5 squared. Okay, so the area over that area is going to be 16 over 25 for that ratio. Okay, so that means that 16 over 25 is going to be 48 over x. Cross simplify, you get x equals 75. So the area is going to be 75 feet squared. Okay? If I put 48 over 75 feet, it's going to simplify to 16 over 25. If I take the square root of 16 over 25, it's going to simplify to my similarity ratio. So this one is not tricky, but just knowing these two relationships are going to guide you on some of your homework problems and some of your test questions. So that's all I got, guys. We'll go over this tomorrow. I'll give you guys a notes quiz potentially tomorrow on some of this, and we'll work on these in class.